All right, well, welcome. We're going to talk about is how to find the derivative of sine and cosine. And I'm going to quickly go through of how to find and what the derivatives of these are and kind of use a graphical example of how to figure these out. All right, so what we have right here is I have the sine function. Now I'm going to graph the sine function. I'm going to try to find what is the derivative of the sine function. I'm going to do this graphically by graphing the different slopes at the different points. So each one of these, this is going to be 0. This is pi over 2. All right, this is pi. This is 3 pi over 2. All right, and this is 2 pi. And we can go down this way. This is going to be negative pi over 2. It's going to be negative pi, negative 3 pi over 2. And then we have negative 2 pi over here. Okay, so I'm going to graph this. So I'm going to actually use green for my graph. So I'm going to put this in green. All right, we got that right there. So for the sine function, at each one of these points, I'm going to graph some slopes. And when you look at this, at all the max and mins, you should know that our slope, or f prime, has a slope of 0. Okay, so f prime equals 0 at all these different points. So that means right here, when I graph that, I'm going to have a 0 here, a 0 here at negative pi over 2. I'm going to have a 0 here at pi over 2, and a 0 here at 3 pi over 2. All right, now, another thing that we notice is right here at pi, notice how this slope actually is going to be negative 1, negative 1. So right here, this slope, as it's going down, is decreasing. So it's going to be negative 1, 2. So we're going to have a negative 1 here. I'll put a dot here. We're going to have a dot right here. Is going to be negative 1 right there. And then finally, we have one more. We have this is going to be positive. So that's going to be positive 1. All right, so it's going to be positive 1 right there. And then we have another one. It's going to be right here. It's going to be positive 1. And we can see that that's going to be positive 1 as well right there. All right, so now when we graph this, hopefully I don't have too many things, but I'm going to graph this function. And you can see as I connect the dots, what is this graph turning into? I have a lot of different dots with lines. But we have this, and we have this graph right here. Now, if I change this color, I'm going to change it to blue. Yeah, change it to blue so you can see it a little better. What is that graph looking at? So as we graphed each slope, so we had 0 here, you can see that my slopes are negative. We get back to, all right, positive 1 right here, and then they go to 0, and then go like that. This is actually looks like very similar to this graph, and actually it's the same thing. Yes, you guessed it. The derivative of sine is equal to the cosine graph. Now, that's one you probably want to memorize and know and love. So the derivative of sine is cosine. Okay, so that's a really important. The next one we're going to do the same thing, but now I'm going to do over here with the cosine graph. So I'm going to go over here and I'm going to find g prime. And I'm going to do the same thing. Well, you can see that right here, all these are the same values. At all my max and mins, I have horizontal tangents. So these are going to be 0. So I'm going to have 0 here, be a 0 here, and a 0 here. Now, some of you might be thinking, all right, well, if this one is cosine, this one has to probably be sine. Well, you're probably close. We'll find out. All right, now right here we have a negative. It's decreasing. It's going to be negative 1. Okay, very similar because these are very, very similar graphs. Here it's going to be negative 1 as well. We are then going to go up here. This is going to be positive 1. Okay, and this is going to be positive 1 there. All right, let's connect these dots and find out what happens here. All right, so here we go. La, 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 connect dots, la, 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 connect that. That's an old 90s, 80s Pee Wee Herman thing, but whatever. All right. Now, this is a very poorly drawn sketch, but it's not too bad. Well, this looks very similar to the sine function, except it appears to be reflected over the x-axis. Because if you look over here, this is the sine function. And when you pass through 0, it goes to be positive, then goes negative, so on and so forth. This one, when it goes to 0, goes negative, then goes to positive. So actually, this is pretty close to sine, but actually it's negative sine of x. And that's what we know. The derivative of sine is cosine, and the derivative of cosine is negative sine. Now that's pretty cool. Knowing that the slopes of sine are actually going to equal the cosine graph, and all the slopes of cosine are actually the opposite of the sine graph. That's pretty intuitive. That's pretty awesome. All right, so using this information, we're going to actually go through a couple problems now. So know these, f prime equals of sine is cosine and so on and so forth. All right, so let's try some. All right, let's find the derivative of these different graphs. So I have a couple problems right here. I have 3 problems. Let's see if we can do this. Now, to find the derivatives, we're going to take y prime, or dy dx. Y prime equals dy dx, just so everybody knows this. All right, so the derivative of x, I'm going to use the power rule, is 1. Well, the derivative of cosine, we just found out, that equals actually negative sine of x. So the derivative of x plus cosine is actually 1 minus sine of x. And that's our derivative. Right here, we're going to keep on going. I have m of x. Now, m of x I have here is x to the 3/5 times cosine of x. Well, how would you find that derivative? Well, we have f, or we have this one, which I can call f, times cosine, which I'll call g. Well, f times g, I have to use what's known as the product rule. And I went through several tutorials on how to do the product rule. But we have to use a product rule here. So we're going to take the derivative of x to the 3/5, which is 3/5 x to the negative 2/5 power, times the second, which is cosine of x, plus now the derivative of cosine, which we know is negative sine of x now, times x to the 3/5 power. Okay, simplifying this a little bit, 3/5, put x to 2/5 right there. We're going to have all that times cosine of x right there. All right, we're going to minus, I'm going to have sine of x, x to the 3/5 power, and that, my friends, is going to be my answer. Not pretty, but that is my answer right there. All right, so use a product rule. So we use a trig with a product rule. Well, let's try one more. We have this, once again, f times g. Well, I guess I'll call it h. F times h, because here's g. So to find g prime, all right, to find g prime, which is dy dx, that's a derivative. Let's find this. Well, to take the derivative of this, we're going to take the derivative of the first, so it'll be 8x, all right, once again, use product rule, times sine of x, plus now, because that's a product rule, times the sine, which we know is cosine now, 4x squared. 1 and 2, we can maybe simplify, factor out x and a 4. So if I do that, I have 4x now here. If I draw 4x, I'm just left with 2 here, sine of x. If I draw 4x, I'm just left with a plus x, cosine of x over here. Can't really do anything else. That, or the top would be your answer. And that's what we got. All right. That is how we can use sine and cosine and do a little bit of trig differentiation. All right, we're going to go through some more tutorials on how to find their other trig ratios in my next lesson. But just kind of give a starter of how we can use the derivative of sine, the derivative of cosine, and some product rule action and find the derivatives. All right, hope this helps you out. Good luck and God bless the rest of your problems.